Vagabond Academy, we like to shoot too. One bullet I say chale, it go make you poo-poo. On a bicycle, so take your trailer. And I'll be famous like Mali and the Whalers. I know they kiss us, fuck all your favors. Nobody bigger than God, Jehovah.
Welcome to today's class. So today we are going to be looking at projectile motion. And we have a question that we'll solve on projectile motion. Now, what is projectile motion? From the board, you can see that projectile motion is a parabolic path traced out by a body with speed under the influence of what? Of gravity. So when we talk about the parabolic path, we are looking at a path that looks like this. So when a body moves through this path, the body is said to undergo a projectile motion. So now, examples of bodies that undergo projectile motion include the motion of a stone released from a catapult can undergo a projectile motion. A ball thrown at an angle to the horizontal can also undergo a projectile motion. Now we have a graph which we are going to use to illustrate this projectile motion and see what happens in the projectile motion. So from here we are plotting a graph of velocity with respect to the distance, and we see that there is a parabolic path that is traced out by the body as it undergoes motion. So which tells us that we are looking at a typical projectile motion. So from this projectile graph, you can see that this is the peak of the projectile path, and from this peak down here to the ground level, we have the maximum height. So the distance from here to here gives us the maximum height, and we are using capital H to represent the maximum height. Now we can also see from the point of projection, to the plane of which the object hits the ground, we are going to have another important distance called the range. So from this point of projection to the point that the body lands, we have the range. So from here, we can also see that there is an angle which is important here, which gives us the angle of projection. So this part here, the angle from here to this point, is the angle of projection. Now the time taken for the object to move from this point here down to the ground level again is called the time of flight. So capital T represents the time of flight. So from here we have the time of flight formula as 2u sine theta all over g, and we have the range as u squared sine 2 theta all over g. Then the maximum height is calculated as u squared sine squared theta all over 2 g. So the question we have here is to solve and calculate for the time of flight, the range, and the maximum height. So we have that an object is thrown with a velocity of 10 meters per second. So the velocity is 10 meters per second at an angle. So the angle of projection is 60 degrees to the horizontal. Now calculate the time of flight, the range, and the maximum height, where we are giving the value of g as 10 meters per second squared. So from the time of flight, we have the formula for time of flight, which is given as t equal to 2u sine theta all over g. So if we are to substitute, we have that u is 10, so we are having 10 sine theta. Our theta is 60, so we have 60 all over g. G is a constant which is given as 10 meters per second squared. So from here you can see that 10 we cancel out with 10, and we are left with 2 sine theta, sine 60, and sine 60 is 0.8660. So that is sine 60. So if you multiply these two, the result will be 1.7 seconds. So that means the time of flight here is 1.7 seconds. Now let's calculate for the range. The range, from our formula, we can see that the range is u squared sine 2 theta all over g. So here when we substitute, we have u, which is the velocity is 10 squared sine 2 of theta, which is 60. So divide by g, which is 10 as a constant. So if we should expand this is 100. So we'll be having 100 sine 2, we multiply with 60, we have 120 all over 10. So 10 can cancel out 100, so what will remain is 10. So we'll be having 10 sine 120, and sine 120 is 0.8660. So if we are to multiply this, we'll be having 8.66 meters. So that means the range is 8.66 meters. Now to calculate for the maximum height, the maximum height has a formula. From the formula we have u squared sine squared theta all over 2 g. So it's good to pay attention to this formula with respect to this. So this is sine 2 theta, but this is sine squared theta. So they are totally different. So this is how we solve it. We substitute for the value of u as 10. This is squared. Then we have sine squared theta. So this sine squared theta is the same as writing sine theta all squared. So these two are the same. So whenever you see sine squared theta, it's the same as sine theta all squared. So in that case, we have what theta is as 60. So we're having 60 all squared all over 2 of g. So here, what we can see from here is that 10 raised to power 2 will give us 100. Then we have sine 60, and sine 60 is 0.8660 all squared. From the formula, divide by 2 times 10 is what? Is 20. So you can see that 0 we cancel out 0 here, 2 we go here as 1, 2 here is what? Is 5. So we have 0.8660 all squared. So if you are to punch this in your calculator, you'll be having 3.75 meters. So that gives you the maximum height. So this is how we can calculate for the time of flight, the range, and the maximum height for projectile motion. So in the next video, we'll see other calculations that are related to projectile motion. Thank you.